Did you know that the asteroid belt lying between Mars and Jupiter is a place where millions of asteroids reside? This vast expanse of space is a celestial shooting gallery, home to a dizzying array of asteroids, each possessing its unique identity. These asteroids come in all shapes and sizes, from tiny specks of dust to colossal bodies spanning hundreds of miles in diameter. And their compositions are equally diverse. Some are chock full of metals, like iron and nickel, while others are rich in carbon or even water ice. It's a cosmic treasure trove, a testament to the incredible diversity of our solar system. But these aren't just lifeless rocks hurtling through the void. Each asteroid carries with it a story, a glimpse into the past that can help us understand the origins of our solar system and perhaps our place within it. As we embark on this cosmic journey, prepare to delve into the mysteries that this rocky terrain holds. How did such a massive collection of asteroids come to be? That's a question that has puzzled astronomers for centuries. Let's delve into some theories. One is the planetesimal hypothesis, suggesting that these asteroids are remnants of the early solar system, the building blocks that never made it to planet status due to the gravitational disruption of Jupiter. Another theory is the nebula hypothesis. This theory proposes that the asteroid belt was once a sort of cosmic donut of gas and dust. Over time, this donut material started to clump together, forming the asteroids we see today. Yet there's also the possibility that the asteroid belt is the result of a celestial demolition derby, leftovers of a planet that was torn apart by gravitational forces. Each theory presents a plausible explanation, but the truth remains elusive. While scientists have theories, the exact process of the asteroid belt's formation remains a mystery. Did you know that Vesta, one of the largest asteroids, could have become a planet? Yes, you heard it right. Vesta, the second most massive body in the asteroid belt, had the potential to graduate from asteroid to planet, but alas it didn't. So what makes Vesta unique, and why did it never reach planetary status? Well, Vesta is unlike its asteroid siblings. Its core, mantle, and crust mimic the structure of Earth, a characteristic typical of planets, not asteroids. Its bright surface reflects sunlight, making it sometimes visible to the naked eye from our home planet. But why isn't Vesta a planet? The answer lies in its location. Vesta resides in the asteroid belt, a region filled with debris from the early solar system. This debris bombarded Vesta, preventing it from accumulating more mass and growing into a full-fledged planet. The story of Vesta's stunted growth remains one of the asteroid belt's most intriguing enigmas. Enjoying our space journey? Don't forget to subscribe, like, and comment on this video. Your engagement fuels our exploration into the cosmos and beyond. Each subscription, like, and comment propels us further into the depths of the universe, unraveling its mysteries. So join us in this journey and let's together decode the secrets of the cosmos. Now, are you ready to dive back into the enigmas of the asteroid belt? Then fasten your seatbelts. Now, back to our cosmic mysteries. Why isn't there a planet where the asteroid belt is? You might be asking yourself this question, and it's a fascinating puzzle that has baffled researchers for years. The asteroid belt, a sprawling expanse sandwiched between Mars and Jupiter, is teeming with rocky remnants from the early solar system. So why didn't these fragments coalesce into a planet? Well, scientists believe that the answer lies with Jupiter. Jupiter, the heavyweight champion of our solar system, has such a powerful gravitational pull that it's thought to have disrupted the formation of a planet in the asteroid belt. This colossal planet's influence would have stirred up the asteroids, preventing them from sticking together and forming a planet. It's as if Jupiter were a cosmic bully, shoving the asteroids around and preventing them from settling down. The missing planet in our solar system is a mystery that continues to perplex scientists. And indeed, the enigma of the missing planet adds yet another layer of intrigue to our fascinating journey through the asteroid belt. Why are the asteroids in the belt so different from each other? This, my friends, is what we call the composition paradox. In our grand tour of the asteroid belt, we've noticed something peculiar. Despite sharing the same neighborhood, asteroids show an astonishing range of compositions. Some are rich in precious metals, while others are packed with water and organic compounds. So why such diversity? Theories abound. One popular explanation hinges on the early solar system's heat gradient. Closer to the sun, it was hotter, and only metallic and silicate materials could withstand the heat. Further out, it was cooler and icy compounds could survive. As asteroids migrated and mixed over time, they brought their diverse compositions into the belt. But this theory doesn't explain everything. Some asteroids don't fit the pattern, giving us more puzzles to solve. The composition paradox adds another layer to the asteroid belt's mysteries. Could asteroids from the belt pose a threat to Earth? This isn't a question we ask lightly. The asteroid belt, with its vast number of rocky bodies, is a potential source of Earth-bound projectiles. When we talk about threats, we're referring to the possibility of these celestial objects veering off their usual path and colliding with our home planet. Asteroid impacts have occurred in the past, and they could happen again. The dinosaurs, for instance, met their fate through an asteroid impact around 65 million years ago. However, it's important to put this into perspective. The odds of a significant asteroid impact are quite low, thanks to the protective gravitational forces of Jupiter and our vigilant space agencies, keeping a watchful eye on the sky. But the universe is a vast and unpredictable place. While we've made great strides in understanding and tracking these space rocks, we can't completely rule out the risk. While the possibility exists, the actual threat level remains a mystery. What role does the asteroid belt play in the future of space exploration? This is a question that has intrigued scientists and space enthusiasts for years. The asteroid belt, with its vast number of rocky bodies, holds untold potential for furthering our understanding of the universe. Imagine a future where we mine asteroids for precious resources. Asteroids are rich in metals and minerals that are scarce on Earth, such as platinum, iron, and nickel. Mining these could not only supplement our planet's dwindling resources, but also fuel long-duration space missions. In addition, asteroids are like floating time capsules, carrying within them the secrets of our solar system's early history. Studying them could provide invaluable insights into the formation and evolution of celestial bodies. So as we gaze towards the stars and dream of what's to come, let's not forget the treasures lying right in our cosmic backyard. The future of space exploration may indeed lie in the asteroid belt. Did you know that asteroids in the belt are often grouped into families? Yes, just like human families, asteroids too have siblings, parents, and cousins. Asteroid families are clusters of asteroids that share similar orbits, suggesting a common origin. They are believed to have formed from the catastrophic disruption of a parent body, akin to a celestial explosion, scattering fragments in various directions. But here's the intrigue. The exact mechanisms that led to these celestial breakups and the subsequent journey of these fragments are still wrapped in mystery. Some scientists suggest high-speed collisions as the root cause, while others point to the gravitational influence of Jupiter. Yet these theories don't fully explain the observed characteristics of asteroid families. How did these fragments manage to stay together, given the vastness and tumult of space? Why do some families have more members than others? What can they tell us about the early solar system? The formation and evolution of asteroid families remain a cosmic mystery. Could there be water on asteroids in the belt? Well, let's dive into that. In recent years, scientists have made a startling discovery: water on asteroids. Yes, you heard right. These barren, rocky bodies, seemingly devoid of life, were found to carry ice and, in turn, water. But how is this possible, you ask? Well, it's believed that when these asteroids were formed billions of years ago, they incorporated water ice into their structure. Over time, this ice could have migrated to the surface, creating a thin, icy crust. Now, the implications of this discovery are immense. Not only does it change our understanding of the asteroid belt, but it also opens up new avenues for space exploration. If we could tap into these water reserves, we could potentially use them as a resource for future missions. The presence of water in the asteroid belt opens up a world of possibilities and questions. So let's keep exploring, and who knows what we might find next. Did you know that the asteroid belt houses dwarf planets? Yes, scattered among the countless asteroids lie some of the most fascinating celestial bodies, dwarf planets. The most famous of these is Ceres, discovered way back in the early 19th century. For many years, Ceres was considered the largest asteroid in the belt, but in 2006 the International Astronomical Union reclassified it as a dwarf planet. Ceres, in fact, comprises about a third of the asteroid belt's total mass, and it's not alone. There's also Vesta, Pallas and Hygeia, all massive enough to be in hydrostatic equilibrium, meaning that their own gravity has pulled them into a roughly spherical shape, a key characteristic of a dwarf planet. These dwarf planets are like miniature laboratories holding vital clues about the early solar system. Their study could potentially unlock the secrets of planetary formation. The existence of dwarf planets amidst the asteroids adds another twist to the belt's mysteries. What more lies undiscovered in the depths of the asteroid belt? A question that lingers in the minds of scientists and astronomers alike. This vast frontier, filled with rocky remnants from the dawn of our solar system, holds an untold number of secrets yet to be uncovered. As our technology advances, so does our capacity to delve deeper into the asteroid belt. Each journey we undertake brings the potential for new discoveries, from unknown asteroid families to uncharted dwarf planets. The prospect of finding new celestial bodies, each holding unique compositions and histories, is a tantalizing one. Furthermore, the asteroid belt may also hold clues to the very nature of our universe. Could there be evidence of life, or perhaps the building blocks of life hidden within these asteroids? Such discoveries could redefine our understanding of existence itself. The asteroid belt, with its untold mysteries, continues to captivate and challenge our understanding of the cosmos. From its formation to the potential for future exploration, the asteroid belt holds many mysteries. We've embarked on a grand tour uncovering the Enigma of Vesta, the missing planet, and the composition paradox that challenges our understanding. Our journey took us through the potential threats these celestial bodies pose to Earth, but also the exciting future of space exploration that they promise. We delved into the origins of asteroid families and the surprising presence of water among these rocky bodies. We explored the existence of dwarf planets within the belt, a testament to the incredible diversity of objects in the cosmos. Lastly, we plunged into the unknown depths of the belt, where secrets remain hidden in the darkness. As our journey concludes, we're left with a sense of awe at the complexity and intrigue of the asteroid belt. As we continue to explore the cosmos, who knows what other secrets the asteroid belt will reveal? Indeed, the mysteries of the universe are as vast as the universe itself.